Hey everyone, welcome to today's webinar. We're just going to give it another minute or so to let folks finish logging in. In the meantime, if you'd like, feel free to say hi in the chat, let us know where you're watching from. If you came with questions, feel free to put them in the Q&A panel, and we will get to them at the end. But in the meantime, we'll just give another minute or so for folks to finish logging in. So to folks who just joined, welcome. We're going to wait another minute or so to let folks finish logging in. In the meantime, if you'd like to say hi, feel free to open up the chat, send a message out, let us know where you're watching from or what you'd like to learn from this session. Or if you have any questions, feel free to post them there too. And we'll get started shortly. I realize it'd probably also help if I shared my screen, so I'll make sure that that's up and running.
Looks like I'm still looking at a starting to share.
Okay, just give me one more second. There we
There
go.
we are.
All right, I think we can get started. So again, hi, welcome to everybody who just joined. This is going to be our office hours session on testing serverless applications, or sorry, service failure flags. Some quick notes before we get started. This is an interactive webinar. We want to hear from you as much as you want to hear from us. So please feel free to enter any questions into the Q&A panel or just hang out in the chat channel if you'd like. After the presentation, we'll get to any questions that you submitted and also any questions that you do submit at that time. So again, feel free, don't hesitate to ask. This webinar will be recorded and the recording will be made available afterwards. You'll get an email with the link to the recording. And if you're new to office hours, welcome. This is a monthly session that we do on various topics related to Gremlin and reliability management. We have a list of our previous and upcoming sessions at gremlin.com/office hours. So if you would like to check those out, feel free to go there. And also just a quick introduction. I'm Andre, a senior reliability specialist here at Gremlin, and I'm joined by Nick Mason, who's going to be leading us through our demo today. So again, we're here to answer your questions and to help you out. So don't hesitate to say hi or ask us anything. So a quick look at our agenda for today. I'll start with just a quick level setting bit about service meshes and their reliability issues. You're all likely familiar with them already, so this is more about just making sure we're all on the same page and actually explaining how they work. Afterwards, I'll talk a bit about how Gremlin helps with serverless testing and service mesh testing. Nick will run us through a demo, and then we'll leave time again at the end for Q&A. All right, so service meshes, what are they? What do they do for us? So in short, service meshes are essentially bridges that connect the different services in our environment. They perform things like DNS resolution, service discovery, traffic routing, traffic shaping, and a whole bunch of other stuff. They're essentially the glue that holds all of these different services in a microservice environment together. Now, one feature that isn't talked about often is that service meshes can also technically do fault injection. If you think about it, they're already shaping network traffic, they're already bridging network connections from our services to the rest of the network. So why couldn't that extend to something like dropping packets or adding latency? This is kind of uncommon though. As far as I know, only Istio supports it, and even then it's more of a novelty than a useful tool. But still, the fact that it's possible just shows how powerful and versatile service meshes can be. And typically the way they work is network traffic routes through a proxy, which runs alongside your applications. It's all done more or less transparently to your application, but there's still a lot of work being done under the hood to make sure traffic is routed to the correct place. So when would you want to use a service mesh? Again, I'm not trying to sell you all on service meshes because you probably use them already and know how they work, but I just wanted to cover some of the key benefits to add some context for later on. So some of the things that service meshes let you do are, for one, decouple your services from each other. Service meshes act as sort of middlemen or intermediaries, so you don't have to send traffic directly from one service to another. They add redundancy to the network. They can route around failures, they can scale up or down to meet demand, and your services don't need to behave any differently. This is all done transparently. There's load balancing too. Service meshes can ease the load on your services by balancing packets across other services or even holding them in queues to make sure that your services aren't being overloaded all at once. And of course, there's discovery. Since service meshes are aware of all the services in your environment and how the traffic flows between them, you can use them to or relatively easily create maps of your services and any services that communicate with like third-party dependencies. So at the very high level, what does this look like? First, you deploy your control plane. This is the brains of the service mesh, the part that maintains the network state, stores your configuration, keeps track of services, things like that. Next are the proxies. This is also called the data plane. This typically consists of sidecar containers that you deploy alongside your applications, and these typically manage the network namespace that they share with your applications. So set opening and closing ports, setting DNS addresses for resolution, things like that. As a little aside, there is a new method Istio introduced called ambient mode, which doesn't require sidecars. But since sidecars are or tend to be the model that most people are familiar with and they're kind of more traditional, I'll just stick with that for simplicity. And so when your application sends a network packet to a service, Istio or whatever service mesh you're using will transparently route the packet to its desired destination. That could be straight to a container, it could be through a load balancer to another container, or it might even be dropped as part of a reliability test you're running. The main idea is that your application doesn't really need to know anything about its destination besides the DNS name of the port that it's going to. The service mesh is supposed to just take care of the rest. So that's all well and good, but like any piece of technology, service meshes aren't perfect. There are different ways they can fail. And I just want to cover some of those ways quickly before we switch over to the demo in a few slides. Now, I just want to caveat this by saying that this isn't an exhaustive list. There are a lot of different ways software can fail. That's one of the things we do at Gremlin is checking for these. But the idea is to just get you thinking about situations like this and how they can actually impact your application. So what are some ways service meshes can fail? Well, for one, there's the sidecar proxy. If that crashes, that's your service's connection to the broader service mesh. So whatever service is running alongside it will also likely fail. It's possible that they just won't be able to connect to the network and it will return an error, but you don't really know that unless you test for it. So that's why I wanted to highlight this one. Another way is one that people don't really expect, but is really common with sidecar is your proxy or your service mesh demands more resources than it can access or that you'd expect it to. If you think about, when you have a surge in demand that causes a service to rapidly scale, let's say a lot of users are suddenly hitting your website because it's Black Friday or Cyber Monday or whatever it might be. Every time your service scales, your proxy has to scale along with it by deploying a new sidecar. And so essentially your resource usage will likely exceed what you expected if you were only focused on your service. And if you don't have a cluster that can scale quick enough, you might run into issues. Third is human error. What if somebody accidentally pushes a misconfiguration that changes the way that traffic is processed, but maybe only for certain requests? Like, for example, requests meant for a specific service get routed to an invalid address or just get dropped entirely. These are a bit harder to find because, again, they're configuration issues. Maybe somebody pushed it thinking that it was correct, but they had a typo or something that resulted in this droppage. You can also test for this preemptively by just seeing what happens and how your service mesh handles packets that might be misaddressed or are malformed. And then last is the control plane itself. Yes, your applications need to be reliable, but if you think about it, if the service mesh itself fails, then it doesn't really matter how reliable your applications are because they won't be able to talk to each other. And a big part of reliability testing is ensuring that when part of your critical infrastructure fails, it can recover quickly, or it can recover at all, but then also that it can recover quickly. That might mean starting up new pods, provisioning new compute instances if you're on the cloud, or if it's a severe enough problem, running an incident response playbook. And again, this isn't an exhaustive list. There are always new and exciting ways that our systems are failing. This is just meant to get you thinking about the different types of failures that can happen with your service meshes, and some assumptions that you can test when you use a product like Gremlin. So speaking of which, what does reliability testing on a service mesh look like? So most of you are probably familiar with experiments and scenarios in Gremlin. Those are for running tests on systems like hosts, containers, Kubernetes, things like that, real like sort of infrastructure level tests. But we also offer a different level of testing that happens not just on the system level, but on the application level. And we call that failure flags. Essentially, if you think about feature flags, this is the same idea, but for reliability testing. And so the key difference between infrastructure experiments and failure flag experiments is that failure flags live inside of your code. That means that you can fine tune your experiment by targeting like not just individual hosts or containers, but also individual requests. So for example, this graph I have shows a few different functions for authentication, vehicle bidding, and vehicle management. We can assume this might be a dealership or something that's running. And these are all connected to a database. So for example, if I wanted to take that authentication function, if this was running in a fully managed environment like AWS Lambda, or even just a hosted service, serverless platform, I wouldn't be able to test it using agent-based experiments because it requires sort of getting to the host, to the infrastructure level. But with failure flags, not only can you run a network experiment on it, you can actually exclusively impact requests from specific users or IP addresses, requests containing a specific HTTP method like a GET or a POST, or of course, just blanket impact all requests. You could even go further and filter on something like database queries. The short story is that whatever data your application has access to is the same data that you can use as a parameter for your test. You essentially just create any key value pairs that you want when defining the failure flag, and you can use that to fine-tune your experiment later on. And the reason I wanted to point this out for service mesh is because you can use the same networking data and rules that the service mesh operates on to also do your testing. So again, going back to the whole idea of specific HTTP methods or IP addresses, or going deeper in impacting requests from specific users. We try to make all of this functionality really available so that you can use that to fine tune your experiments. And I'm sorry, I just noticed I didn't click through the text, but I think you get the gist of what I was referring to. Essentially, the way it works is you add one or more failure flags, gesture points into your code. You deploy your application. Those failure flags appear up in Gremlin in the web application. So then you can use that to run experiments and fine tune it however you'd like. And so before I actually get to the demo, or before Nick gets to the demo, rather, I wanted to show off a just example of what this could look like. Also, I found this really great animation from, sorry if I mess up your name, Shanaj Kumar on LinkedIn, and just really wanted to show it off. Essentially, what we had are three containers running on Kubernetes and connected via console using Envoy as a proxy. So if we wanted to take a setup like this and run tests on it, we'd first add a failure flag to our application. Oops, sorry. Add a failure flag to our application. And from there, we would introduce failure points between the application and the other services that's communicating with. So that can include things like adding latency or triggering exceptions or even running custom behaviors. Essentially, we have a lot of flexibility in what we can do and how we can accompany, or rather, how we can experiment on this. So again, kind of pointing it out, we add our failure flag to our container. And from there, we have our various failure points where we can then introduce these failures. So again, we can say, what if the application can't connect to the proxy? What if it can't resolve a DNS name because it can't connect to Envoy? What if any services that it talks to consistently return an HTTP 500 area, indicating an internal server area? And what happens if, let's say, it takes us 200 milliseconds longer to talk to our dependencies, or 500, or even a full second? How does that impact our application's performance and usability, and also our stability? And really, the way you want to approach this is build your tests based off of assumptions of how you think your application would work. So our assumptions are that our service mesh is fast, it's always available, it would always resolve DNS names, the right targets, and that any request we send to other services will always return back as successful. So those are really good starting points to start building these experiments and really validating that your services meet those standards. And if not, that's totally fine. Like no system is perfect. You can just take your learnings and implement fixes, deploy those fixes, and then retest your applications to make sure that your fixes are not only effective, but your application is still working the way you expect it to. And then from there, automate these tests to make sure that they run regularly. Regressions are a thing, even in reliability, just like in QA and coding. So being able to continuously test for and monitor for those regressions is going to be really helpful to making you sure that you maintain your reliability. So that was a whole lot of content to cover. I'm going to stop talking for a few minutes and I'm going to hand it over to Nick, who's going to walk us through a demo. So take it away, Nick.
Alrighty, let's get my screen shared and get started. There we go. Ba-bum. All right, we should be looking at the Gremlin Failure Flags. You seen that okay, Andre?
Yep. All good.
Perfect. Perfect. All right. Well, welcome everybody again. Just to recap, my name's Nick Mason, Senior Solutions Architect here at Gremlin, and my job is to work on cool stuff like this with customers, prospects all around the world. So, if you're a customer out there, you might have with me in the past, or if you're new to Gremlin, looking forward to chatting with you in the future. But what I want to do is I want to expand on what Andre talked about. We gave a little bit of context about what is a service mesh, what are some options or opportunities that we can apply within a service mesh environment, and ultimately, how does that relate back to Gremlin with fault injection, running chaos experiments, and ultimately learning where there might be potential risks within your application? And, the first thing I want to start with is, there are a lot of different service meshes out there, right? Today, we're going to be looking at the Istio service mesh through the Envoy proxy, as Andre mentioned. But, there's a lot out there and they're all very different, right? And with that, there are many different opportunities and goals that can be accomplished using a service mesh. And the goal that I want to set for us today, what I want to focus on is to bring application level fault injection and impacts to our service mesh environment. And in this specific demo, we have the Gremlin Envoy extension, which is essentially how we're able to get Gremlin installed within your Istio environment. Now, what we're going to do is we're going to be running through application level chaos experiments on a sample app that I deployed. Now, before I get into the actual application itself, what does it mean when I say application level targeting? And what I mean by this in relation to the service mesh is being able to target based on your mesh names and the HTTP request primitives. So let's go now and take a look at the architecture of this sample bookstore application that I spun up. And you can see here there are several different services, some depending on others, resulting in basically this bookstore application. And what we've done is we have instrumented the mesh that is deployed with our Envoy extension. And what that has done is now all of the sidecars that are running next to these replicas result in these pods phoning home to Gremlin to interact with our failure flags control plane. And that's a little bit what Andre was talking about a little bit earlier. Now, what this does is it gives us the opportunity to inject application level faults at the actual proxy layer. So there's no application level instrumentation required for this particular integration. I think that was one of the questions that was just in the chat. Because we're adding the Envoy extension, you actually don't need to do the traditional method with failure flags, if you're familiar with that, where you need to go in and actually annotate your code in order to declare these failure flags where you want to. And this is a good thing, right? If you're going to scale, the product that you're going to need to use needs to be extremely low code or something that people can inject into their common service frameworks, or, they pretty much have to take place at the network proxy layer when a service mesh is in place. So let's go ahead and now that we've seen the architecture, let's go ahead and take a look at this bookstore application itself, right? We'll refresh this a couple times. You can see here that we have these book reviews, we have some book details, just like you saw in the architecture diagram, right? And the reason why I'm doing this is basically I just want to show we're generating some traffic, right? The mesh itself is going to observe that traffic and it's going to observe the dependencies between these different microservices. And each of those dependencies are going to get reported up into the failure flag subsystem as a failure flag. Now, if we come over here to the Gremlin UI, we're here in the failure flags section, and this is what I was talking about. So we have three different sections here in failure flags. We have experiments, we have the failure flags themselves, and then we also have your services here. So In this particular example, we have the details service as a failure flag, and this is observed anywhere that the service is instrumented in making a call to that detail service. So in this particular example today, that would be the product page, right? We saw that here. The product page is sending information into the details service. And what we want to do is we want to simulate an experiment where the details page was having some issues, some kind of issues, right? Maybe there was a bad deployment and something wasn't coming up. And one of those examples that Andre mentioned in the last slide before I took over was injecting custom HTTP response codes, right? So in this particular example, we're going to take a look at this experiment here. We have an experiment where we're going to be injecting a 500 response code to see how the product page reacts when the details section is having issues. So before we get into the actual implementation and running of this experiment, I want to take one step back for any of you who are unfamiliar with how failure flags work within Gremlin. There are really three major components that make up a failure flag experiment. The failure flag that you want to run the experiment on, and this is really the point in the code, or in this case, the service mesh, either an ingress or an egress, as well as this could also be targeting HTTP level attributes, right? In this case, we've said we want any inbound requests to the detail service. So anything that's calling the detail service, even if it's something else, not the product page, will experience the result of this experiment. And then lastly, over here, we have the effect. And in this case, this is basically the parameters of your experiment. We want it to last for 5 minutes. We want the impact to be 100% of the matching results. And in this particular example, we are going to inject a 500 HTTP response code and see what happens. So let's go ahead and click run here. We'll get this experiment going. And what's going to happen over here in a couple minutes once this thing loads up is we're going to observe how we actually degrade once this details section is no longer available from the experiment itself. So we'll come in here, we'll give it a couple seconds, and basically what we're trying to observe is, can I still interact on the bookstore, right? Am I still able to come in and read reviews? Yep, looks like I'm still able to read reviews. Looks like, unfortunately, now we're seeing that there is an error on the details section. This is what we anticipated, and right, this is what we're trying to test. And ultimately, we're failing gracefully, right? We're checking everything around this. We want to make sure that we can still interact with the rest of the application. And that's exactly what's happening here, right? So let's go ahead now. And now that we've made our observations and, we've taken some actions internally, obviously this takes place a little bit longer than what you're seeing right now, but for the sake of simplicity and kind of the duration of what we have today, what I'm going to do is I'm going to go ahead and halt this experiment. And what that's going to do is in a couple seconds here, it's going to bring back my details page. So we'll wait a couple of seconds here. We'll see how that works. And then everything will be back to normal. As you can see here, I can come back in. I can look at the ISBN number, the type, the language, whatever it may be. Now, before I conclude, the final thing that I want to talk about is how do we add this extension to your application, right? And the way that you add this extension to your application is we add a few lines of code, basically as an annotation to your deployments that we want to target or where we want this thing to be deployed. We bring in another init container to actually bring in the configuration along with our secret metadata, of course. And finally, we define our envoy filter for our Istio service mesh within that deployment itself. So those are kind of the three steps that you're going to be doing. Obviously, if you guys wanted to hop on a call individually and kind of walk through what your particular environment looks like, we'd be more than happy to set that up and kind of dive a little bit deeper into the specifics of your use case. But yeah, hopefully you found this interesting. Hopefully, you could see that, with the service mesh in place, there's still a lot of opportunity to do chaos experimentation and fault injection, reliability management as a whole. And yeah, thanks again for watching. And Andre, I'll pass it back over to you.
Awesome. Thanks, Nick. So I saw a couple questions pop up in the chat, so I figured before I go back to the slides, I'll just address those really quickly. Um, One of them was providing detailed steps on how to annotate code with failure flags. If I actually just share my screen real quick. So honestly, the best way I could recommend, like Nick said, if you hop on a call with him, like he's super intel he works on this stuff all day, every day, essentially. He really knows his stuff and he can help you get through it. So um, definitely like feel free to reach out to us. But in the meantime, we do have documentation on our website about deploying failure flags, not just on the typical method using the sidecar container and stuff like that, but also deploying it on Istio. Um, can't go into all the details here because that would take forever, but essentially, if you come to our website, head down to failure flags, we have instructions on all of our different deployment methods and supported platforms there. Um, let's see. The same goes for showing how to instrument your code to actually connect it. So with Istio, it's a bit easier, but with other service meshes or other platforms, it's a little bit more involved. I'll just show an example with Python here. Or sorry, Node.js. Essentially, what you would do is we have our sidecar that you deploy alongside your application, but we also have an SDK that you bring into your code. And this SDK is where you define your failure flag. So let's say you have this Node.js application running on Lambda. You have your handler method here. You would just add this await gremlin.invoke failure flag. You'd give the failure flag a name like HTTP ingress. And optionally, you can also add labels. Now, this is the essentially the metadata that Gremlin takes from your application that gives you that ability to filter and target specific requests. So in this case, we're pulling the HTTP method, but then also the path, the URL that the user is requesting. So we could go back into Gremlin and say, okay, I want to run this experiment, but I only want it to impact a 500 or 200 method and a path to, let's say, /user/authenticate as an example. This is what lets you to do that. And this is available in all of our different SDKs, Node, Python, Java, Go, and .NET. So you can use it there too. And the other question I saw pop up is explaining deliveries and impact. So failure flags tracks two things. First is making sure that it delivers the experiment to your application or your service. But then also, because you can do request filtering, it also tracks how many requests have been impacted. So essentially, the delivery is did our experiment get to our service? And the impact is did the experiment actually impact this request that went through? So that's why you'll see different numbers for those. And that's why you'll see both of those show up alongside each other. Just to give you a bit more insight into that. And I saw another question come up. Will your Envoy filter work with ambient mesh? I believe that's something that we're looking into. I don't know if it's available right now. Keep me honest, Nick, please.
Yeah, it's something actually kind of work in progress in terms of exploring kind of different solutions for that. Obviously, ambient mode is different than sidecar mode. It's kind of new to the block, if you would. So stay tuned on that in terms of how we approach that.
Cool. But yeah, let's see. So with all that being said, we've reached the end of the demo and of this session. Like I mentioned, if you have questions or more questions that you haven't already asked us, we'll be more than happy to answer them. We'll be around for a few more minutes. In the meantime, if you have to go, just want to give you some quick links that you can use to learn more or just get better hands on Gremlin. First, if you're new to Gremlin, welcome. We have a free 30-day trial that you can use to just get your hands on the platform and see how it works. This is available at gremlin.com/trial. Like I mentioned, we have a documentation around failure flags. That's just at gremlin.com/docs/failure flags overview. That's a good starting point to get into it. And as before, we have these going as monthly sessions. We also really want to tailor these sessions around topics that you're interested in. So please let us know by contacting us, sending us emails, using smoke signals, whatever your preferred method of communication is, and let us know what topics you'd like to hear about. But yeah, we'll just keep an eye on the chat and see if other questions come in. Yeah, like Emmanuel asked us if we need additional licensing for Istio or other service meshes on top of their existing Gremlin subscription. and Nick answered that we can take a look at your Gremlin subscription and see if you're clear to use failure flags. If you don't see it pop up in the navigation menu, just feel free to reach out to us, ask us what it would take to get that enabled. We'd be more than happy to work with you. Oh, and I am not seeing anything else come in. You're more than welcome, Eric. I'm glad this was helpful for you. If you do think of questions after the webinar ends, no problem. Just fill out the form at the end, or feel free to to reach out to us by going to gremlin.com/contact. We're always more than happy to hear from you. In the meantime, you'll get an email with a copy of the recording if you want to watch it later or share it out to friends or coworkers. But yeah, in the meantime, thanks so much for joining us and have a great rest of your week. Take
Yep.
care.
Thanks, everybody. Cheers.